Okay, so here's the solution for the handout. What we're doing is looking at these graphs and answering questions relative to the value of the function and the limit. So the first one is this graph. So it's this piecewise function. And if we look at f of 1, so here's x equals 1, we see there's a hole, but then we have the dot here. So the value of the function is 3. If I didn't have this dot, we'd say the function does not exist. Now the limit as x approaches 1 is going to be equal to 2. That's the y value. These both are approaching, even though the value of the function is 3. As you get closer and closer to 1 from both sides, it's approaching y equals 2. Then we have this discontinuity. The value of the function is 1 because the dot is down here. This is empty. The limit does not exist because if you approach from the left-hand side, you get y equals 1. If you approach from the right-hand side, you get y equals 2. So we would say it does not exist. Now, as far as the one-sided limits, if we approach x equals 2 from the left side, we're approaching y equals 1. And from the right-hand side, we're approaching y equals 2. And because these two limits are not the same, that's why the limit does not exist there. F of 3, we have this case that's probably a, well, these are two functions, different functions, so it may not necessarily be indeterminate, but the function does not exist because there's no dot here and there's no continuous line. But the limit does exist because from approaching from the left side, I'm approaching y equals 3, and from the right hand, I'm approaching y equals 3. Okay, next group, f of 3, the value of the function is 0 because the dot's down here. The limit as x approaches 3 does not exist, and that's because if we approach from the left-hand side, the limit is 0. If we approach from the right-hand side, the limit is 1, and because these do not equal each other, the limit does not exist. Now at f of 1, so here's at x equals 1, the function does not exist. Got this hole. Now the limit is going to be equal to 4 because whether we approach from the left-hand side or the right-hand side, we're still approaching y equals 4. So that's a case where the function does not exist there, but the limit does exist. At 2, the function does exist. It's equal to y equals 2, but the limit is actually, we're approaching y equals 3 from the left side and the right side, so the limit would be equal to 3. Now if I go back here just one step, didn't ask for it, but seems like we're missing something here. Oh no, we did that first. Okay. Okay, the next one. Here's x equals 2, so the value of the function is going to be equal to where the dot is. So the function value is y equals 2. The limit of the function at x equals 2 does not exist. And again, that's because if we approach, in this case, from the positive side, we're approaching y equals 2. Whereas if we approach it from the left-hand side, we're approaching y equals 1. And these are different, and therefore the limit does not exist. So here the function exists, the limit does not exist, but the two one-sided limits do exist. Okay, same graph. The value of the function at x equals 1, it does not exist because we have a vertical asymptote. Now the limit as you approach x equals 1 also does not exist even though they both go to positive infinity. But if we did the one-sided limit, here's from the left-hand side, we would say that equals positive infinity, and from the negative side and from the positive side, it would also equal positive infinity. Remember, infinity does not exist, so this is really telling us which direction the curve is going. Is it going up to infinity, or is it going down to negative infinity? And the last group here is right here at 3. So this is a case where the function does not exist because we have this dot, this open circle, but the limit does exist. And in this case I have this extra little bit. So the limit exists, and the limit is y equals 3. And if I look at the right side limit with the plus sign, I'm coming down here to y equals 3, so that's 3. And I'm going from the left-hand side to the point, and it's 3. And because the left limit and the right limit are the same, then the limit exists. But because we have a hole, the function does not exist there. And then the last group, we're going to start here at 1. So here we just have a non-smooth curve. The function exists, the limit exists, so there's nothing super unusual going on there. Just the fact that this is not smooth. It is continuous. It exists. So the value of the function at x equals 1 is y equals 3. The limit is 3. Now here at 2 we have this jump, this discontinuity. The function does exist because you have a dark filled in circle, so that's f of 2, f of x equals 2 is y equals 2. The limit as you approach x equals 2 does not exist. So if we see going from the right hand side, the positive side, the limit is 4. I must have those later on. I didn't. Okay, I just didn't put it in there. So the limit of, if I had this, where is it here? Yeah, if I had, I didn't ask you for it, but if I had the limit as x approaches 2 from the negative side of f of x, that would be equal to 2, which is the value of the function. Okay, then we have f of 3, so here's 3. So f of 3 does not exist because we have another vertical asymptote. Does not exist. And you can see the limit does not exist. They both go to negative infinity. But we can assign a positive or negative infinity to the one-sided limit. So coming from the right-hand side of x equals 3, you can see it's going to go down to negative infinity. And likewise, if you come from the left side, you get negative infinity. And then finally at x equals 4, the function exists, but it's down here. So the value of the function is y equals 2. The limit is not y equals 2, it's what's up here. So as you approach x equals 4, the function's approaching y equals 4 from both the left-hand side and the right-hand side. So this is the left-hand limit because it's negative, so that's approaches 4, and the right side approaches 4, and that's why the limit, oh, there's that other one I was looking for. So I didn't ask for it. So the limit from the negative side is 4. I didn't write down positive 4. I just want to make sure you paid attention, which I almost didn't. So the value, the limit on the right-hand side would be 4, and the limit on the left-hand side would be 4. Therefore, the limit's 4, but the actual function equals 2. And then we have back to the other one. The limit is f of x as you approach 2 from the negative side, that's the other condition that I was wondering about. So that's equal to 2. So you can turn that in with your homework.